All right, so this whole unit, you guys, is about rational expressions. Rational expressions is when you take like two polynomials, like let's say x plus 1 and 2x plus 3, and you make a fraction out of them. That's what a rational expression is. We're going to talk today about graphing a special kind of rational expression, one that looks like this. So that's our goal for the day there. All right. I'm going to get you guys started on this, but then I'm going to let you guys do most of it after that. So we have two charts that I want to complete and fill in here. So let's do this one. I'm going to plug in -1. If I were to plug in -1 for x, 24 divided by -1 would be -24. If I were to plug in -2, 24 divided by -2 would be -12. If I were to plug in -3, that would give me -8. Okay, so you're just going to keep doing that for all the numbers here. Once you're finished with this table, we want to connect the dots. Okay, then you're going to do this table and connect those dots. They're going to be two separate pieces, just so you guys know. So do one graph for this table and one graph for that table on the same chart here. So -1, -24 would be like about here. -2, -12 would be here. -3, -8 would be about here, and so on. So go ahead and find all those blanks, connect your dots, and then we'll see what that graph looks like. Okay, so this is what our graph should have looked like here. Something I want to point out to you guys is that it has asymptotes on it. Those are invisible lines that it can't cross, so it can't cross that line there, and it also can't cross this line here. Even though there's two parts to this graph, like there's the top right and the bottom left part, it's still technically one function. It's just that it's split up. So that's what these things look like. So as I mentioned earlier today, we're graphing functions that look like this. We're starting off with something like this, though, that looks a little bit more basic. Let's review some transformation stuff. If you guys have a function, f of x, then we talked about how these things here do different things to the function. So here, we'll look at that first. If you have a positive h, what that does is that moves your graph to the left, actually. If you have a negative h, it translates it to the right. So it just slides it to the right and left based on the h value there. So the number that you add or subtract to the x, that just slides your graph to the left and right. The number that you add or subtract outside the parentheses, that shifts your graph up and down. So if you have a positive k value, that's a translation up. If you have a negative k value, that's a translation in a downwards direction. And finally, if you ever have a negative in front of your function overall, it flips your function upside down. Okay. So let's see what that looks like, you guys, real quick. I've got up here on the graph. This is the graph that we had earlier, right? And I just want to show you some things that happen here. So the first thing I'll do is let's say I'm going to add a number on the outside here. Like I said, I'll probably add a little bit more than one, though. Let's say I add 5 to it. Well, think of this kind of like your inside of the parentheses, like your outside. So adding 5 on the outside, that should shift my graph up. Okay. So let's see what that looks like. So notice it's the same graph, but now notice that the horizontal asymptote is not at 0 anymore. It's been shifted up to 5. Okay. Another change I could make is maybe I can add a number or subtract a number from the x. Like let's say I do minus 10. That's going to shift the graph over to the right 10 spaces. So now not only is the horizontal asymptote been shifted up here to 5, but now the vertical asymptote has been shifted over to the right 10 spaces. Okay. One final change I could make is like, let's say I put a negative in front of this whole fraction here. That'll flip the graph upside down, so it looks like that. Okay. So those are our transformations that we learned a little while ago. And what I want you guys to get out of that is that notice that whenever I did this, if I put plus 5 here, that's my horizontal asymptote. It was originally 0, but if I put plus 5, that shifts it up. So this is my horizontal asymptote. And if I put a minus 10 here, that shifts my graph to the right. But when we do that, the vertical asymptote shifts over to the right also. So now the vertical asymptote is this number. Notice it's the opposite sign, though. It says negative 10, but we're at a positive 10. So keep in mind that these two numbers here and here represent your asymptotes, basically. And then from there, we're good to start graphing. So here's our steps for today. You're going to be given functions that look like this. The first thing you're going to do is you're going to sketch your vertical asymptote. That's this number here, but you're going to do the opposite of it. So if it's minus 2, the vertical asymptote will be x equals positive 2. So use the opposite sign of h. And also keep in mind, if you're ever missing the h or the k, they're just 0. Step 2, we're going to sketch the horizontal asymptote. That's wrong. We need to, no, that is right. Sketch the horizontal asymptote, but we need to fix this. You guys, this should not say x, this should say y. So can you change that to y on your paper? We want to sketch the horizontal asymptote, y equals k. That comes from this number here. Notice that one's not an opposite sign. So we do the opposite sign of h, but not the opposite sign of k. And then we're going to sketch the curve. Okay. Now I'm going to show you two different curves that we're going to look at here. You guys should draw this on your paper. If you have a positive in the front of your a over x minus h, then it's going to look like what we had before. It's going to be top right, bottom left. But if you have a negative in front of that fraction, if you have a negative in front, it flips it over so it'll look like this instead. It'll be top left and bottom right. It switches the signs so everything gets reversed. All right, guys, so take a look at the last PowerPoint slide that I printed out for you guys. Have the steps on there. I'm just going to be following those to graph what this function looks like. All right. So step 1 says sketch the vertical asymptote, x equals h. So x equals h. So h is this number, but the opposite sign of that number, so it's negative 2. So that's my vertical asymptote. Vertical means up and down, so I'm going to be sketching a vertical up and down line at negative 2. I like to make these dotted because it's not like it's technically not supposed to be a line that you see when you graph these. They're just an invisible barrier that your graph can't cross. So I make it dotted so I see it, but it's really supposed to be invisible. Step 2 says sketch the horizontal asymptote. The horizontal asymptote is y equals k. So that would be this number here. And for the k, you don't change the sign. So I'm going to keep it as a positive 2. And that's my horizontal asymptote. So I'm going to do a horizontal line at 2. Okay. Step 3, we have to decide which of these curves we're going to use. Is it going to be this one? Or is it going to be this one? And it has to do with whether or not our fraction has a negative in front of it. We have no negative in the front, right? So for this one, we're going to use this. So my graph then, my final answer would look like this. That's about it. So we just got to put those curves in there. They get flat against the asymptotes like that. One is on the top right, one's on the bottom left. So sketch your vertical asymptote, sketch your horizontal asymptote, put your curves on there, you're good to go. Just remember that for the vertical asymptote, it's opposite sign. All right. And that one's x equals some number. All right. So look at it. See, just figure out what value I'm going to put there. What's the vertical asymptote? Take a moment, see if you can figure it out. What do you think, Cynthia? That's right. Is it going to be positive or negative? It's negative now, but we do the opposite. So it's going to be positive. All right. So let's go ahead and sketch that. Positive 2. So Lily, what's my second step? Good. Horizontal asymptote. That one's a y equals. See if you can figure out what number goes there. Y equals blanks. Take a second. Amethyst, what's y equal to for the horizontal asymptote? Actually, it's going to be this number here. It's going to be negative 3. So let's plot that one. All right. So the next thing I'm going to let you guys do, and these steps that I'm writing over here, you guys don't have to write these in your homework or anything. I'm just showing my thought process. You really can go right to the graph on these. That's fine. But on your notes, I would do it. That way you have something to look at later. But homework, don't worry about it. So we have two possibilities. My graph is either going to look like this, or it's going to look like this. So I'll give you guys a second to ponder which one you think it is. So it's going to be the one on the right, and the reason for that is because we have a negative in the front there. Okay, so your first curve is going to be in the top left. Your other curve will be in the bottom right. Okay. That's it. All right, so go ahead and write down number 3. We're missing something. So are we missing the h or are we missing the k here? We're missing the h, the number next to the x. All that means is that it's 0. The same thing applies to the k if the k is missing. So you don't have to do this on your homework, but on your notes, I would suggest maybe putting a 0 there for now. But in the future, in your homework, you don't have to do that. So if the h and the k are missing, they are 0. All right, so let's begin. Take a minute, see if you guys can figure out what the vertical asymptote would be. What do you think, Armani? What would the vertical asymptote be?
-0?
Yeah, and you can just say 0. That's fine. 0 doesn't matter whether it's positive or negative, but you're right. We would change the sign technically, but it's not necessary here. All right, step 2, we want to find our horizontal asymptote. So, Amaya, what's our horizontal asymptote? Yeah, +1. So I forgot to graph these, so let's do it. 0 would look like this. A vertical asymptote at 0 is right on the y-axis. And then y equals 1. That's my horizontal asymptote right there. Go ahead and put your curves on there and see if you guys can figure out what the curve should look like on this one. You're all done. So I'll put just a couple practice problems. I'll call some people to present their problems in about 10 minutes or so, and then we'll be done.